Okay, so we start with fluid mechanics. Okay, am I audible to you?
Yes. Okay.
Fluid mechanics. So first of all, we have to define what is a fluid, correct?
Yeah.
So how do you distinguish between a solid and a fluid? Can you tell me two or three distinguishing points?
Uh,
No, whatever comes to your mind. So
so
basically,
I know.
fluids are substances which can flow,
Okay.
correct? Substances that can flow. So we need substances that can flow. Okay. So you will say that liquid and gases both can flow, correct?
Yeah.
So yeah, you are right. Both the gases and liquids both are called fluids only. Okay. So you can call
Okay.
up both of them as fluids, correct? So we have got
Yes.
liquid. So we can talk of them as, yeah, we got liquids and we have got gases, correct? Now there are two distinct properties. So when you say fluid mechanics, primarily what we are looking at is we are looking at liquids. Okay.
Okay.
Acha, now if you take a liquid, what all properties can you think about the liquid? Very something which is intuitively coming to your mind. Say first
It
of all, you
has.
say that it will have mass, correct?
Yes, and it takes up volume.
Yeah, so it will have density also, correct?
Yeah.
Now that's a very important thing. One it will have mass, then it will have volume, and so it will have density, correct? Acha, what is
Yeah.
density by the way? How do you define density?
Density is mass divided by volume.
So we can say that mass per unit volume is density, correct? Okay,
Yeah.
now remember that in a liquid, the density plays a greater role. Like in solid, we hardly talk about density, we mostly concentrate on mass. But whenever we talk about fluid mechanics, it's the density that's going to be of importance to us. Okay,
Okay.
I can start with a very simple example to let you how to do it. Like for instance, let's say that we are taking a liquid. So here we are taking a container which contains a little bit of liquid. So let us say at present it has a liquid like this. Okay. Now what we are
Okay.
going to do is we are going to take a substance and submerge a
Yeah.
solid in this liquid. Correct.
Okay.
So what will happen to
Yeah.
the liquid? The liquid will rise. Correct. So it was originally
Yes.
here. Now it will go up to here. Correct. I make a small
Yeah.
line just to show that there is a difference between the earlier one. Correct.
Yeah.
Now remember, interestingly, the volume of liquid that has risen will be equal to the volume of the solid that is completely submerged, correct?
Yes.
So volume of liquid that has submerged is equal to the volume of liquid that has risen, correct?
Yeah.
Is it clear? Fine. This
Yes.
part was very easy to understand. What happens to the solid? Does it experience any additional force because I've kept it in a liquid?
Yes.
What force does it experience?
It experiences buoyancy force.
Yeah, so it experiences a upward force. We can say it experiences an upward thrust, correct? And the upward thrust is experienced like this, correct?
Yeah.
Can you tell me what is the quantum of upthrust it will experience? What will
Uh.
be the quantity of upthrust it will
Oh.
experience?
In newtons.
No, if I tell you how will you find out the amount of upthrust that the body is experiencing?
Oh. Um.
Upthrust, or we call it as buoyancy.
You do that by doing the multiplying the density times the volume times the gravitational field
Volume of
strength.
what?
Yeah.
Volume of what quantity?
Volume of the liquid.
Which liquid? There are two liquids. One is the extra liquid that is erosion, and one was the original liquid that was there.
Um, the extra liquid that has risen.
Okay. And the buoyancy you say is equal to what? Come again.
The buoyancy is equal to the density rho times
It's
the
actually equal to weight of the liquid displaced, correct?
oh,
Am I right?
okay. Yeah.
Hello. And to calculate the weight of the density, the volume displaced is known to us, correct?
Yeah.
Volume displaced is known to us. And when you know the volume displaced, of course, you can easily calculate the, as you rightly said. So we have, first of all, you have to remember that buoyancy B will be equal to the density of the liquid that is displaced into the volume of liquid displaced into G. Okay, and that will be equal to weight of the liquid displaced, correct? Do you
Yeah.
know the name of the principle we are using this for?
Um,
It's called Archimedes principle.
Archimedes. Yeah.
You learnt it in school. Fine. So now you understood why this density stuff is very important to us. Okay.
Okay.
Okay. So remember that in fluid mechanics, even though fluids can be classified as both liquid and gases, our concentration will be mostly on liquids. And the one more important, most important properties that we learn about liquid is going to be its density. Correct. So we have to be very clear about density. Can you tell me what is the density of water?
I think 1,000 pascals.
How can density be calculated in Pascal, my dear?
Wait. Oh no, that's pressure.
Take your own time and tell me what is. See, density is mass per volume, correct?
Yeah.
So it will be equal to kg, correct? Divided by meter cube, correct?
Yeah.
So it is correct. The density of water is going to be 1000 into what? 1000
Oh.
kg per meter cube.
you-
Now remember, for doing calculations, we generally use it as 10 raised to 3, correct? Kg per meter cube.
Mm.
Or you could write it as 10 raised to 3 kg m raised to minus 3, whichever way you want to write. Okay.
Okay.
So this is learned by us. Now another thing that the liquid does is it exerts pressure. Correct. Both liquid and gases. Gases to that extent gives you more pressure than liquid is exerting. Correct.
Yeah.
So if you have driven a car and you have driven, if you have looked at a heavy vehicle, then something is written on the heavy vehicle saying that it has got pneumatic brakes. Correct.
Yes.
The pneumatic brakes are more powerful in the sense that the braking is very instant, and it is used generally used for heavy vehicles like you can get trucks or buses or something like that, correct? Which require a
Yeah.
greater force. So pneumatic means it has to do with gases. Hydraulic means it has to do with something with water, liquid. Okay.
Okay.
Now, how do you define pressure? Yeah, tell me, how do you define pressure?
Uh, the force exerted by.
So we talk
Uh,
about force divided by area, correct? Very simply.
oh yeah.
Yeah, force upon area, correct? Force per unit area is taken as pressure, so its unit will be how much? Newton meter square, correct?
Yeah.
Or you can write it as Newton per meter square. Okay.
Okay.
Standard 1 Newton per meter square is taken as Pascal. 1 Newton per meter square is taken as 1 Pascal. Okay.
Okay.
Now, a very important feature of measuring pressure would be by a liquid column, correct? Okay.
Yeah.
So now let's say that we take a liquid column. Give me some time to draw this stuff. So this is a liquid column, a normal tube, and I have filled liquid, let me say up to this level. Okay.
Okay.
So let me say that the height of the liquid is h. This height is h. The area at the bottom is a. So tell me how much will be the volume of liquid? Hello.
Um,
Volume of
it,
liquid will be equal to area into height, correct?
yeah.
So let us say that density of the liquid is rho. Density is given as rho. It's a Greek letter we use. So how much will be the mass of the liquid?
Um,
Mass will be equal to density into volume, correct?
yeah.
Because we said that density is mass upon volume, correct?
Yes.
So mass will be how much? Mass will be
Uh,
density into volume, correct?
yeah.
Now put key in the value of volume, you will ultimately get this will be equal to rho into A into H, correct?
Yes.
Okay, so now tell me what is the mass of this liquid? Mass I have got, now tell me the weight of the liquid. Weight again we know is mass into acceleration due to gravity, correct?
Yeah.
So this whole thing now turns out to be rho A H into G, correct?
Yes.
Now look at it carefully that the weight is acting at every point at the bottom, correct? It's acting at every point on the liquid, correct? And it is
Yeah.
acting vertically downward. Alright?
Okay.
Okay. Now according to firstly we have defined pressure. Correct. So pressure
Yeah.
due to liquid column will be equal to the total weight upon area. Uh, is it correct?
Okay. Yeah.
Okay. Now if you write all this stuff, you will get this as rho, you will get A, you will get H, and you'll G, and you'll divide it by area. So now tell
Okay.
me what will be the pressure exerted? It will be equal to H into rho into G. Now again look at this, the rho becomes very important here. Correct?
Yeah.
So we summarize this and write it in one sentence. We write it as, one second. Yeah, pressure exerted by a liquid column, correct, is equal to what? Pressure exerted by liquid column will be equal to, first
The
of all,
height
we
of.
need to know the height of the liquid column.
Yep.
So we have height of the liquid column, then we have density of the liquid, and then we have acceleration due to gravity. Is this clear?
Yes.
Okay, now let's do a very simple exercise, a little bit of calculation. Okay,
Okay.
first of all, I'll remove all this stuff. Too many things. Okay, so let's say
Mm.
that we have a mercury,
Mm.
dense mercury, correct? Its density
Mm.
is equal to 13,600 kg meter cube, correct?
Yeah.
Meter cube. Good. Hmm. Its height is 760 centimeter, 76 centimeter, correct? And
Yeah.
acceleration due to gravity is 9.8 meter per second square, correct?
Yeah.
All right. Yeah, now calculate the pressure exerted by this mercury column.
Okay.
The formula is very simple. So your pressure is equal to H into rho into G. Be careful about the conversion. When you say 76 centimeter, it will be equal to 0
So
0.76 meter
yeah,
into 13,600 into 9.8. You got the facility of your calculator, so please tell me the answer.
yeah, it's 101,292.8.
It will be equal to 1.013 into 10 raised to 19 meter cube. Okay. Well, this is
Okay.
basically the atmospheric pressure at sea level. Okay.
Oh, okay.
Nandiri, of course, when you go to a hill station, the height of mercury column will reduce, so will the pressure reduce, correct?
Yeah.
Okay. So this is very important to us because we will be doing a lot of calculation over here. Now remember, this term is very important to us for the reason that 10 raised to 5 Pascal is taken as 1 bar. Is taken as 1 bar. It is another unit of what is called as um, pressure. Okay.
Okay.
So just make a note of this and then we'll go ahead.
Okay. Okay. I noted it.
Okay. Now we want to know how to measure pressure. Okay. So pressure
Okay.
is measured by a thing called as, we call it as a manometer, correct?
Hmm.
So is measured by a instrument called manometer. Okay. Can you tell me, have you ever done about a manometer in school? Heard about it?
Mm, I might have seen it, but I've never heard of it.
See, basically, what happens is, have you ever seen somebody take blood pressure? Maybe when you visited the doctor or somewhere, must have gone with your
Yeah.
grandparents or something like that. See, he
Yeah.
either there is a, nowadays, of course, it is measured digitally. Okay,
Hmm.
some years back, we had something like this. See, we had a small tube, and this tube was bent in the form of a U tube. Okay,
Hmm.
of course, nowadays YouTube is to watching videos. Okay, fine. Now, first what you do is you fill this with a liquid, mostly mercury. So it is filled with mercury like this. Okay.
Hmm.
Now you'll notice that both sides have the same end, correct? They are equal.
Yes.
Now, if you want to measure some pressure due to something else, like suppose you want to measure pressure of the blood in your vessel, so you attach the substance over here, correct?
Hmm.
Or it may be water that is coming from a pipe. So now
Hmm.
what happens is on this end we have an additional pressure that is due to A. So let us say PA, correct?
Hmm.
Okay. Now when you do this, what happens to the liquid? The liquid actually drops. Liquid in this tube actually drops down, correct? It goes down.
Hmm.
So we will notice that what happens is the liquid will actually drop.
Hmm.
Okay, and it will rise in the other tube. Okay. So on
Okay.
one side the liquid will be less, the other side the liquid will be more. Here the see the liquid has dropped, correct?
Yeah.
And here the liquid has risen, correct?
Yes.
Now, if you notice this is the equilibrium level. At this level, pressure on this side is equal to pressure on this side, correct?
Yeah.
Of course, pressure on this side is equal to what? Pressure on this side is equal to pressure due to A, correct?
Yeah.
Here the pressure is due to A. So here the pressure is due to A.
Okay.
So here the pressure is due to A. And what is the pressure here? That is due to mercury column, correct?
Yeah.
So let us say that this height over here is H.
Okay.
Let us say that this height over here happens to be H. Then this pressure will be equal to H into density of mercury into G. Now since both of them are on the same level, the pressure that we are trying to measure should be equal to H rho into G, correct? And we use the same principle of pressure exerted by a liquid column. Did you understand how we measure?
Yes.
And this is called a manometer. This what we call is called a manometer. Okay.
Okay.
So generally, whenever we talk to pressure, we talk about the height of the liquid column, even though we are indirectly counting it. Okay.
Okay.
Acha. Another thing that we do in measuring is the measuring the atmosphere. Okay. That is
Hmm.
measuring the atmospheric pressure. So let us say that we consider our Earth. We all know that the Earth is engulfed with the atmosphere, correct?
Yeah.
So this is your Earth over here, and it is completely engulfed with what is called as the atmosphere, correct?
Yeah.
Now, what will the atmosphere do to any person standing on the surface of the Earth?
Uh,
It will exert a pressure, correct? It is gas, isn't it?
yeah.
So,
Yeah.
any person on the surface of the Earth or any substance on the surface of the Earth, including the surface of the Earth, will experience a pressure due to the enormous amount of gas that is above it, correct?
Yeah.
The actually the atmosphere goes much ahead, much above the thing, correct? Now,
Yeah.
if you have flown in a plane, they talk about pressure dropping, correct? They give you
Yes.
some initial brief whenever you fly, which says that whenever the pressure drops, correct, what happens? The oxygen mass fall down, correct, automatically.
Hmm.
So when you fly to a certain height, now normally if you look at it, your plane will be flying at something around 70,000 feet above your normal sea level. So obviously the
Hmm.
pressure will be much lesser there, correct? Because as we have seen, pressure depends upon the height of the liquid or the gas, correct?
Yeah.
So higher you fly, lesser the pressure. Now on the
Yes.
surface of the earth, we are used to breathing at normal pressure, correct?
Yes.
So we make effort to exhale air. The air comes automatically fills in inside because outside pressure is more and our pressure inside our lungs is less. So what will happen? Air will go to our lungs, correct?
Yeah.
So if you want to exhale air from your lungs, you will have to put an effort, correct?
Yes.
Now suddenly you go to a place where the pressure is less, correct? Then you will have difficulty in
Hmm.
breathing because you are used to the pressure on the surface of the earth, correct?
Yes.
That's what happens. So in an aeroplane, the pressure is maintained as the normal pressure that you experience on the surface of the earth, correct?
Yeah.
Now we want to find out how do you measure the pressure due to atmosphere, okay?
Okay.
What we do is we do a very simple thing to begin with. We, as I told you, we have a small tube, correct? So we take a
Yeah.
tube and then you fill this tube
Hmm.
with mercury right up to the top. So it is completely filled, correct?
Yeah.
It's completely filled with mercury over here. So it's completely filled here like this. It's filled. Then we take another flat vessel, or we call it as a trough like this, and notice that it is also filled with mercury to a certain level, correct?
Yeah.
Now this thing which you see, you invert it. So you are now inverting it like this, correct?
Yeah.
When you invert, what will happen to the mercury inside? It will obviously fall, correct?
Yeah.
It will
Yes.
fall inside. But now something interesting happens. When it falls down, notice that there are two pressures. One is the pressure due to atmosphere, correct?
Yes.
Inside the tube, it is the pressure due to liquid column, correct?
Yeah.
So here it is the atmospheric pressure that we want to measure, and in this case, this is the pressure due to the mercury column, correct?
Yeah.
Now let us say that the height over here turns out to be h. Let us say that
Okay.
this height is h, correct? So the
Yeah.
pressure due to mercury column will be equal to what? Will be equal to height of mercury into G into density of mercury, correct?
Yeah.
And that will be equal to atmospheric pressure. This is how you measure a atmospheric pressure. And last time I had made this calculation and told you that it will be equal to 1.013 into 10 raised to 5 Pascal, correct?
Yeah.
Okay. So this is how
Okay.
you measure atmospheric pressure, and this particular instrument that we use over here is called a barometer. It's called a
Barometer.
barometer. Okay. Of course, these are very rudimentary ways of doing it. Nowadays, everything is digital. You don't need to go through. I just wanted to emphasize the principle on which it works, correct?
Yeah.
Well, electronically also you do the same thing. Instead of you visually doing it, there is a sensor which transmits the thing to a chip which calculates the pressure and gives it into in form of digital number. Okay.
Okay.
But the underlying principle still remains the same. Only thing is you don't visually see, mark and calculate what is the pressure. Calculation part is done by the microchip or the controller inside the machine, and the actual height is taken in by what is called as a sensor. So did you understand two things? One is pressure due to liquid column, and then another thing we understood is atmospheric pressure. Okay.
Okay.
Now we go to the next aspect of liquid. So let us say that we take a substance which is filled with liquid. So this is a vessel that we have filled liquid with. Okay. And we
Okay.
exert a pressure over here. So let us say we are exerting a pressure P over here. Now because the liquid is completely enclosed, this pressure that you exert at this point is transmitted undiminished, that is without undergoing any change to every
Hmm.
part of the liquid. Okay.
Okay.
So this pressure will be experienced by every point inside the liquid. Okay. So to
Okay.
every point the same pressure is transmitted. Did you understand this point?
Yes.
Okay. And it is undiminished, that means it is not changing. Okay, and this particular term is called as Pascal's law.
Okay.
He did a lot of work on this. Of course, Pascal did a lot of other things. That's why the unit of pressure is taken as Pascal. So this is Pascal law. A
Okay.
very important application of this is called as hydraulic principle. You must have heard the word hydraulic brakes, correct?
Yes.
We have hydraulic principle. Now what is hydraulic principle? So let us say that, let's say we are taking two liquid columns. So we have got liquid column here like this, and then
Hmm.
we have got liquid column this way, okay, here, and then we have got a liquid column this way. Fine. Now we fill it with liquid. Yeah. Now as you can see, the two arms are not of the same thing. So you got a vessel which is made up of two arms. One is a narrow arm and one is a broader arm, correct?
Hmm.
And just for some numerical analysis, let us take that the area in the smaller arm is A1. So here this distance over here, this arm is A1, whereas this one which is rather broader is A2. Now let us say
Oh.
that we exert a force F1 over here. What will
Hmm.
happen? This force will be transmitted to this end as F2, correct? The
Yeah.
force over here will be F2. But we have just said that the pressure over here will be equal to the pressure over here, correct?
Yes.
So the Pascal's principle tells you that P1 will be equal to P2. Now what is P1 equal to? It will be equal to F1 upon A1 should be equal to F2 upon A2, correct?
Yeah.
Now let's take a case that your A1 is, let us say, 20 square centimeter. Remember, it is square centimeter.
Okay.
And your A2 happens to be 100 square centimeter. The force
Okay.
exerted by you on the first part is 20 Newton.
Hmm.
Calculate the value of F2. Formula is there right in front of you. Just do a little bit of calculation.
Okay.
So what will happen? In place of F1, I will put how much? 20.
It's gonna be 100.
20, and I won't change because it's anyway will get cut down, correct? This
Yes.
will be F2 and this would be
So it's
100.
100 squared.
So I get my F2 will be equal to 100 Newton directly, correct?
Yeah.
So see, my 20 Newton is transferred to 100 Newton without doing anything, correct?
Yeah.
That is how the braking of our vehicle works. So you have maybe about a 10-ton bus or a truck which is moving, and the driver just presses on the brake by his feet, correct? So
Yeah.
the force exerted by him is hardly anything, but the whole truck is brought to stop, correct?
Yes.
You must have also seen those large machines which are used to excavate, correct? To remove
Yes.
mud or make big thing, or you may use it for making big holes in the earth, or you have got those oil rigs, correct?
Yeah.
They all work on the principle of hydraulics. Okay.
Okay.
You got a plane that lands, and when it lands, what happens? The first thing to come in contact with the ground is the landing gear, correct?
Yes.
And the landing gear is virtually taking the whole weight of the plane, isn't it?
Yeah.
There again we use hydraulics, correct?
Yeah.
Okay. So did you understand the principle of hydraulics?
Yes.
Okay. So we are basically done with this. Now we have also already done Archimedes principle, correct?
Yeah.
Yeah. So let us summarize. First of all, remember when we talk about fluid, it is made up of liquid and it is made up of gases. Primarily, we will be talking about liquid per se. Now, the most important characteristics of a liquid are its density and at the pressure it exerts. Correct. Pressure is
Yes.
quantified by using something called as a liquid column. The pressure exerted by liquid column depends upon its height, it depends upon its density, and it also depends upon the acceleration due to gravity at that point. So pressure exerted by liquid column is taken as H rho g. Okay.
Okay.
Now this principle is used both to measure pressure in a U tube, whether you are measuring the blood pressure of an individual or you measure the pressure of a air in your tire. Okay.
Okay.
Then we move down to use the same thing to measure the atmospheric pressure. Okay.
Double.
Okay.
Okay.
And then we have what is called as Pascal's principle, where we see that when a liquid is there in an enclosed vessel and to one end we have exerted pressure, this pressure is spread undiminished to every other part of the vessel, and we use this to apply for brakes or hydraulic mechanisms, correct?
Yeah.
And that is called the hydraulic principle. Is this clear?
Yes.
In the next class, we'll go ahead and see some advanced versions. We look at viscosity, we look at viscous drag, okay?
Okay.
And then we look at the energy that is exerted by a liquid, okay? Is this clear?
Okay. Yeah.
Sure then. Bye. When are you free this week?
Um, I won't be free from Wednesday till my Wednesday till I think Sunday or Saturday because I'll be in the robotics again.
Saturday, Saturday, what time will you be free?
No. Oh, if um I don't think I'll be available Saturday because I might come home around 10:30.
Fine, then we'll do one thing. We'll
Yeah.
keep the next class on next Sunday only, okay?
Okay.
Yeah.
And
In
if
case you have a free session, one day before you give me a message, okay?
okay.
I'll leave a message, and if I'm available, I'll take a class. Okay?
Okay.
Sure. Bye.
Okay. Bye.